We're going to have a few videos on 8.2, just called Algebra of Functions. First, we're just going to talk about how to add, subtract, multiply, and divide them. So here's some function f. F is 3x plus 4. Here's another function g. G of x is x minus 6. We use f and g's just so we can tell them apart. It's like their names. Instead of calling some function Scott or Terry or Sam, we call them f and g just to be precise. Well, this right here, this says f plus g of x. That means I'm going to take my f of x function and add it to my g of x function. Well, f of x was 3x plus 4. G of x was x minus 6. I add these up and I get 4x minus 2. So f plus g of x is 4x minus 2. Let's take the two functions and add them up. This is nice, because now if I wanted to find f plus g of 2, now I know this looks like f plus g times 2. It's not that. This over here is f plus g of 2. I can now take this 2 and plug it into my function. So f plus g of 2 would be 4 times 2 minus 2, which is 6. That's one way to do it. You find f plus g of x, and then once you know that function, you have the function rule written here, then you do f plus g of 2. The other way to do this, however, f plus g of 2 could also just be thought of as f of 2 plus g of 2. And f of 2 we know is 10. G of 2 we know is negative 4, because 2 minus 6 is negative 4. And 10 minus 4 gets you 6. Either way, you'll do the same thing. You could actually do f of 2 plus g of 2, or you could have already found f plus g of x and plug in a 2 for it. Same thing with subtraction. Now I have f minus g of x. I'm going to subtract g from f. So I'll do 3x plus 4, because f of x, I'm doing f of x minus g of x. So 3x plus 4 minus x minus 6. It has to be in parentheses because you're subtracting the whole entire function g of x, the whole function. And that gets you 3x plus 10. And if you're not sure how I got that plus 10 there, this negative has to distribute. So it's 3x plus 4 minus x plus 6. The negative distributes, and that gets you 3x plus 10. So now to find f minus g of 10, there's two ways I could do it. I could do f of 10 minus g of 10. F of 10 would get me 30 plus 4 is 34. G of 10 would get me 10 minus 6 is 4. And 34 minus 4 is 30. Excuse me for 1 second. Okay, continuing. One of the options was to do f of 10 minus g of 10, which was 34 minus 4 to get 30. The other option is, we've already found f minus g of x. F minus g of x was 3x plus 10. It was this. So we could just plug a 10 in for x. Somehow that seems off. It should be 2x. 3x minus 1x is 2x. So we plug a 3 in for x, a 10 in for x. So now I'm going to do f minus g of 10, but I know that f minus g of x was 2x plus 10, so we're going to do 2 times 10 plus 10, and that also gets me 30. There's adding, subtracting. Multiplying, dividing looks really similar. Here's the same f, here's the same g from the last slide. F times g of x would be 3x plus 4 times x minus 6, and this has to FOIL, so it's 3x squared minus 18x plus 4x minus 24. So it's 3x squared minus 14x minus 24. That is f times g of x. And now if I wanted to find something like f times g of, I'll pick something kind of simple like 5. I have two options. One is to plug a 5 into these x's. See what that is. 5 squared is 25, times 3 is 75, 14 times 5 is 70. This puts 5 minus 24. So that's a 4 right there, trust me, and that's negative 19. Or I could find f of 5, which is 19. G of 5 which is -1, and multiply those to get -19. So multiplying and dividing, not much difference. The division, however, has one issue. That bell's going to ring 5 times so you can hear it. I'm going to do f over g of x. 3x plus 4 over x minus 6. From this point forward in math, excuse me, I'll pause again.
One reminder.
From this point forward, whenever you see a variable on the bottom of a fraction, you have to have an alarm go off in your head where you think, ooh, something special happens here. X cannot be 6. Because if x is 6, 6 minus 6 would be 0, and we cannot divide by 0. So if you ever aren't sure what x cannot be, you can just take the bottom factors, any factor you find, and set it equal to 0. Because what we don't want. In fact, you can say x minus 6 cannot be 0. We cannot let x minus 6 be 0, and then solve that equation. You'll get that x cannot be 6. 6 is excluded from the domain. 6 cannot be one of the x values that we have. But other than that, with division, you just do what we did last chapter, where factors simplify, cancel whenever you can. Maybe you'll need common denominators if you're adding and subtracting at some point, but you do the division. So if I wanted to find f over g of 2, just plug a 2 in, there, and there. It'd be 10 over -4, which is -5 over 2. If I wanted to find f over g of 6, well, I can't, because 6 can't work. That would be undefined. You'd be dividing by 0. Finally, we can add and subtract functions if they're graphs. This blue graph here will be f of x, and the red graph will be g of x. If I want to do like f plus g of 3, I would do f of 3 plus g of 3. F of 3 is 5. G of 3, so I went here. G of 3 is -2. 5 plus -2 is 3. It's like f minus g of 1. Well, I would do f of 1 minus g of 1. F of 1 is 4. G of 1 is -4. Throws that up to 0. Thank you. Hope that was helpful. Have a great day.